Imagine, if you will, a vast savanna under the blazing sun of prehistoric Africa where our most ancient relatives amble, their feet stirring up dust that has settled undisturbed for millennia. Within these forebears reside the humble beginnings of an incredible journey. A journey that has taken us from primitive apes to the astronauts who stride among the stars. This captivating odyssey of evolution is not just a tale of survival, but a complex narrative of adaptational artistry, played out over the eons by the relentless forces of nature. As we peel back the layers of time, we uncover a saga marked by transformative leaps, from mastering fire to exploring the cosmos. This story shows not only where we've come from, but also hints at the untold possibilities of where we are headed. The journey of human evolution commences over 6 million years ago, with the split from our common ancestor with chimpanzees, our closest living relatives. This era heralds the emergence of the first hominins, creatures not yet human but already walking the path towards bipedality. Fossil finds like Lucy, a well-preserved specimen discovered in Ethiopia, illuminate these formative years. She provides crucial evidence of early bipedalism, giving us glimpses into the lives of these trailblazers of human evolution. Detailed analyses of Lucy and others show that while they walked upright, their life remained tethered to the trees, balancing a lifestyle between ground and canopy. This arboreal adaptation likely provided safety and nourishment, an evolutionary advantage in the predator-rich expanses of ancient Africa. The environmental pressures of their time, fluctuating climates and expanding savannas, forged adaptability into their very bones, driving them towards new evolutionary paths. As forests receded, these intrepid beings ventured increasingly across the open landscapes, setting the stage for remarkable evolutionary developments. Advancing on the evolutionary timeline, approximately 2 million years ago, another monumental character enters the stage. This species, with their larger brains and more human-like proportions, marked a significant leap forward. One of their defining achievements was the harnessing of fire. This critical development was not merely about warmth and protection. It fundamentally transformed their diet and, consequently, their physiology. Cooked food is easier to digest and provides more energy, catalyzing brain growth and facilitating geographic expansion. The controlled use of fire allowed them not only to inhabit colder regions, but also to create the first social hearths, predating the modern campfire. Here, around the crackling flames, social bonds were forged and knowledge was passed from one generation to the next through stories and shared experiences. The tools of also saw a marked improvement, moving from the simple stone flakes used by their predecessors to more sophisticated hand axes, evidence of increasing cognitive abilities and fine motor skills. Parallel to the story of Homo sapiens, other human species were writing their own histories. Neanderthals in Europe and Denisovans in Asia represent branches of the human family tree that flourished for tens of thousands of years, only to vanish mysteriously about 40,000 years ago. The fossil record and genetic evidence reveal that these were not brutish cavemen, but sophisticated beings with complex cultural practices. Neanderthals, with their robust physiques and adapted cold weather strategies, were skilled hunters and craftspeople. Recent archaeological discoveries have shown that they created art, buried their dead, and even cared for the disabled within their communities. Meanwhile, the lesser-known Denisovans have come into the light primarily through genetic studies, which have uncovered surprising levels of interbreeding among these ancient human species and Homo sapiens. This intermingling has left indelible marks on the human genome, influencing everything from immune responses to adaptations to high-altitude living among modern Tibetans. Advancements in genetic technology have shaken the tree of human evolution, revealing complex relationships and migrations that were previously hidden. Through the meticulous analysis of ancient DNA, scientists have retraced the steps of early modern humans as they spread out of Africa and into the rest of the world. This genetic detective work has uncovered networks of interbreeding and migration that shape the diversity of human populations today. Studies have pinpointed key genes that have afforded humans unique advantages and adaptations. For instance, the FOXP2 gene, often dubbed the language gene, provides insights into how language capabilities might have evolved, giving Homo sapiens a critical edge in social organization and culture dissemination. As we delve into our genetic code, we're not just uncovering the echoes of our past, but also beginning to influence our future through genome editing technologies that may one day allow us to overcome diseases or adapt to new environments on Earth or beyond. The tools of early humans tell a story of gradual sophistication, from the primitive sharp stones of the older one to the intricate metal alloys of the Bronze Age. Today, we wield tools that allow us to leave our planetary cradle, tools so complex and powerful that our ancestors would regard them as magic. The journey from making simple tools to constructing space stations orbits around our remarkable capacity for innovation and problem-solving. Technologies like these are not merely marks of human achievement, but beacons of human potential, shining light on both our past accomplishments and the paths forward. As we stand on the shoulders of millions of years of evolution, looking out into the cosmos, it's clear that the journey of human evolution is far from over. The same curiosity and adaptability that led us from the savannas of Africa to the surface of the moon will continue to drive us as we explore new horizons and perhaps, one day, new worlds.